42.6903.
6935 grams. So this is grams of, what is this? Grams of C2H6. Yeah? Now this amount right here, this might be a little bit weird. What the heck is this? What does this even mean? This is the amount of grams that have been used in the experiment. So this is the amount that has been used up. This is C2H6. That is used. Okay. So if you think about it like a fuel tank, this is how we did before. Think of it as a fuel tank. At the beginning of the reaction, you've got a lot of O2. Put O2 right here. O2 is right here, and this is the C2H6 right there. Right? So that's the start of the reaction. Then the reaction goes, and here's time. Over time, the O2 gets totally burned up, and that's our limiting reactant. So the O2 gets completely burned up. But there's some of that C2H6 left over. That could be more like this. Okay? So, at the beginning, we had a lot of the C2H6. In fact, we had 76 grams of that. At the end, we want to figure out how much is left over in our tank after this reaction has all been used up. So, what we just did is we just calculated the amount that has been used up, this dotted area. That's the amount that has been used up. Okay? So when this is 0, that's the amount that was used up. So this is 42.6935 grams. So we want to know what this remaining is. We want to know what that value is. So it's pretty obvious now what you have to do to find the final answer is take this, subtract by that. And then I'll get you your final answer. Okay. Yes?
In my packet, I don't, I have the part we just did, but I don't have, the moles. I just have, you times it by the grams.
By the second part.
By the second part, not the first part.
This
I
part
don't
right
have the
here?
first part.
You guys don't have the excess reactant
We
part?
have that part.
but
I'm
not-
saying the 2/6 moles part.
Yeah.
Like that, I don't have that.
You don't have...
I just have here, I got the limiting reactant, and then I times it by here.
Yeah.
See?
Oh, okay. You guys don't have the excess reactant.
No, but I don't think general has it.
Oh, that's right. Okay, so you don't have the excess reactant. That's fine. So this is, I guess this is extra. This is only for honors. The excess reactant. Okay. So the honors has excess reactant. You guys don't need to worry about the excess reactant if you're in general. Sorry about that. Oh yeah, that's what you get if you're in honors. So congratulations, you get this extra. If you're in general and you're squinting your eyes at this and saying, oh my god, what the heck is this? I've never seen this before. Well, you've got a good reason to squint your eyes and say, oh my god, I've never seen this before. Because we didn't cover it. Okay, so you don't need to worry about this excess reactant garbage. It's not garbage, it's actually fun. Right, Harris? She can say yes right now. You can't see it on camera. So over here we've got, this is I guess just for the honors kids. At this point, when you've got this many moles of H2O produced, you convert that many moles of H2O produced back into the excess reactant. And this is how you do it. Then you turn that excess reactant in moles into grams of excess reactant. And then that is how much you actually have used at the point where the reaction runs out. Yes.
We're still doing it tomorrow, right?
Yeah.
Okay.
Okay. So our final excess reactant that's remaining after the oxygen has been all used up is 76 minus this number right here. Now since you only have 2 sig figs, this is going to turn into something like this. 76 minus 42.6935. So whatever this is going to be rounded to 2 sig figs. Okay? Okay.
The test is
Thursday, right?
Yeah, everybody else is Thursday. Period 1 honors class is
We were ahead.
tomorrow.
Why is that going?
Because you guys were ahead, your day ahead. All right, so that's excess reactant. Let's talk about percent yield now. I'm going to erase everything except for that blue stuff again.
Yeah, what's up?
Are you paying attention right now?
Actually, but this stuff that
Is that cool? Okay, back up to the board right now. We're going to talk about the percent yield. Okay, let's assume now that we want to first find the theoretical yield. Let's try to find the theoretical yield first. And everybody's done this before, so we can all do this together.
Really hard problem one time.
Oh, I'll save that for the test. Just be comfortable with how you're doing this process. It's all the same process. It's always the same. Think about what you're turning into what.
Because I'm so bad.
This is what you get for your limiting reactant. When your limiting reactant makes a product, this is how much product it makes. Before we had the other excess reactant giving you some kind of a product up here, but it was more than the limiting reactant, right? Right. So this is the maximum amount of product you can make. But this is only in terms of moles. To find your maximum amount of product you can make in grams, you've got to change those moles into grams. And this is what you were talking about, Rose. So you're going to take that number, 4.25, 9194 moles of H2O. And now we're going to turn that into grams. And we turn it into grams by multiplying by its molar mass, right? So it's 1 mole of H2O. And that's going to be, I'm glad you got a sneeze on tape. It's going to be that many grams. Right? That's how much a mole of H2O weighs. Right there, 18.0148. And this answer right here is going to give us our maximum amount of product that we can make, which is also known as theoretical yield. Yes, good.
Actual yield is done.
So this is going to be grams of H2O. So let's go into this.
$76.7.
76.7. So to round this for everybody else, for general, you don't need to worry about rounding it. If you get, did you get anything else besides that?
2.8.
2.8. Report it to 3 decimal places for general. Always report it for general. Now for honors, you guys have to round to sig figs. Unfortunately, you have to figure out what the sig fig is. In this case, there's 2 sig figs. So it will be 77 grams. That will be your theoretical yield. And this is your theoretical yield right here. Theoretical yield. In theory, this is how much H2O you should make. Correct? Correct. So in theory, that's how much you should get.
Yes.
However, let's say that you messed up in this experiment. Let's say that you didn't maybe you didn't turn up the heat all the way. Maybe all this wasn't reacting. Okay, maybe you're turning around and distracted and putting scissors on people's stuff, and I don't know, some other things you get distracted by during labs. Those are unstructured time, and you like to talk about hockey and stuff. Maybe, I don't know. Just saying. If that happens, let's say you don't get a full amount of this theoretical yield. In fact, you only get, I don't know, 71.9 grams of H2O. So this is your actual amount. Okay?
Why is 71.9?
I'm just making it up. I'm making this up. Okay? I'm totally making this up. Okay? You do the experiment, you actually run the experiment, and you only get this amount. Yeah.
Will we have Eric carry forward?
Eric, yes.
Bad.
No, that's
Like
good.
what?
Yeah.
That means that if you have like something in error and like you use
Yep,
that
you
error
guys will
makes
get
like calculation,
Oh,
then
nice.
it's like still a
Yeah, it is.
So like you get this.
Yeah, you're welcome. So, let's suppose that this is our actual. So what would be the percent yield that you would get? If this is your actual, and you knew that this is your theoretical, what would be your percent yield?
Something
How would you set it up? Yeah.
Actual
93.
over theoretical times 100.
Yeah, so it's this over, this is my big over sign.
Sorry.
This over is going to be 76.
93.7%.
And then you're timesing it by 100, right? Times by 100.
That's pretty good for messing around with decisions.
That's pretty good. What do you get as the answer?
93.7%.
93.7.
And you'll give us the actual yield, right?
Yeah. Or, what happens, you guys could also figure this out. Let's say that I just tell you that your percent yield, let's just say your percent yield is this. Can you tell me what the actual is? Yeah.
You divide by 100 and then multiply by the theoretical.
Yeah, so it's going to be actual over this, whatever this is. 76.72. 8 times 100. So you divide by 100 on both sides, which would cancel this 100 out,
Okay.
right? And then you would multiply by the 76.72.
Sure.
And then you get the actual.
Let's do this. I'm ready.
Wait, Mr. Sam.
Yeah.
You do 76.728 divided by 100. Is that what you said?
No.
To get
First
the
step
percent?
to get. Okay. So let's suppose that instead of giving you the actual, what I do on the question, let's just say that I give you instead. I give you the percent.
Yeah.
Okay. Let's just say that I do that. Now I give you the percent, and you know what the theoretical is already because you just calculated it out. And then I'm asking you what the actual will be. Okay? To figure that out, you have to take your theoretical down here. You put it down here in this little equation. It's actual over your theoretical times 100, and it equals that percent yield. Okay? That percent yield, that's what I give you in the problem. Okay? It's just a number that I pick. And then you can take this, divide that by 100. Okay? With me so far? That crosses off this 100 over here. It gets rid of that. And this is going to be divided by 100. That'll move the decimal place over. Right? Then you multiply both sides by 76.728. And what that'll do is it'll get rid of it on this side. And it'll multiply this by 76.728. And that'll get you what your actual yield will be. Okay? Alright. Good. So that's percent yield. And now we've got your empirical formula. Any questions on this? You guys good?
No.
Good. You're not good.
What? No, I don't have a question.
Okay. Empirical formula. Empirical formula is pretty easy. This is the last thing. Let me go get a problem.
He's gonna fall.
Aaron,
There's one more.
Okay, so yeah, that's wrong.
Oh, okay.
Okay, bye.
I see the
Okay, I like this one. This one's really nice. Let's say that we did this before in class, but I'm going to do it again, just because it's a nice, good example problem. It's like right in the middle of the road. It's slightly hard, so it's